Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 13, Summarizing Bivariate Categorical Data in a Two-Way Table. Okay, we all know what a summary is. Hopefully we all know what bivariate means. Two variables, x comma y, dependent, independent. Categorical data, not numerical data. For example, if I said, how tall are you? And you said 5 feet 8 inches tall. And I say, how tall are you? And you said 4 foot 3. Then those are numbers. So that'd be numerical data. It's values, numerical values, where categorical data would be like, what's your favorite color? And you tell me blue. What's your favorite color? Red. What's your favorite color? Green. Those are different categories. So we're going to do categorical data, X, Y, bivariate data, summaries in a two-way table. Okay, so here we go. On an upcoming field day at school, the principal wants to provide ice cream during lunch. She offers 3 flavors, chocolate, strawberry, and vanilla. She selected your class to complete a survey to help her determine how much of each flavor to buy. Answer the following question. Wait for your teacher to count how many students selected each flavor, then record the class totals for each flavor in the table below. Which of the following 3 ice cream flavors is your favorite, chocolate, strawberry, or vanilla? Okay, so I'm going to use my calculator to make a random list here because when I make my videos, it's usually before I teach the lesson. So I don't have any data yet on what my classes chose over these 3 different flavors. So what I'm going to do is I'm going to use a calculator. So here's my calculator, and I'm going to go to math, probability, and I'm going to do the random integer. And I'm going to choose integers between 1 and 3. So I'm going to let chocolate be 1, strawberry be 2, and vanilla be 3. Those are my outcomes. Okay, so I'm just going to do this randomly, whereas in a class setting, you just simply ask the students, of these 3, what's your favorite? Okay, so if I hit enter, I got a 2. That means that that was a strawberry choice. So I'm going to do 5 at a time. Ask another, there's chocolate, vanilla, 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 vanilla. Okay, so I'm going to do a tally below and then I'm going to write it in. So I have 1, 2, 1, 1, and 4 3s. So 1, 2, 1, 1, and 1, 2, 3, 4 3s. So that's 6 people. And I'm going to do this again. And I'm going to do a total of 20, I believe. Yeah, let's do 20. So we've got 6 so far. So 7, 8, 9, 10. That'd be 2, 1, 3, 2. So that'd be 2, 1, 3, 2. That's 10 now. So I'll do 5 more. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 was this 2 right here. So 1, 2, and 4 3s. So 1, 2, and 1, 2, 3, 4 3s. Okay, and I'm going to do this 5 more times. So I'm going to hit enter 5 times. 1, 2, 3, 4, 5. So 3, 1, 2, 3, 2. 3, 1, 2, 3, 2. Okay, so I had 3 chocolate, 6 strawberry. Is that right? And 11 vanilla. 5, 5, 1, 5 and 1, 3. Yes. Okay. So 11 plus 6 is 17 plus 3 is a total. I did ask 20 people, and there is my outcome. All right, so let me just erase these tallies. And there is an estimate of how we would fill this table. Now number 2 says, which ice cream flavor do most students prefer? And in this problem, it is vanilla. Okay, because that was the number that was chosen most frequently. Which ice cream flavor do the fewest students prefer? And the answer is chocolate. What percentage of students preferred each flavor? Okay, so I'm going to do chocolate, I'm going to do strawberry, and I'm going to figure out how many chose vanilla. Well, in order to find a percentage, you take the total choices, or the total number chosen for chocolate. How many chose chocolate over the total? So 3 out of 20 like chocolate. 6 out of 20 preferred strawberry, and 11 out of 20 preferred vanilla. Okay, it says to round to the nearest tenth of a percent. So percent means out of 100. So if you can get these to 100, well, guess what? If I multiply 20 times 5, then I will get 100 in my denominator, won't I? So if I multiply the top and bottoms by 5, then 5 over 5 is 1. I'm not changing the value. So 5 times 3 is 15 100ths. 6 out of times 5 is 30 out of 100. And 11 times 5 is 55 out of 100. Well, percent is a decimal, so 15 divided by 100 is 0.15, 15 100ths. This is 30 100ths, so that's 0.30. And this is 55 100, so 0.55. It says round your to the nearest tenth of a percent. Okay, well, these are percentages here, so 0.15 is 15%. 0.30 is 30%. And 0.55 is 55%. Since I chose 20 for my denominator, I did not need to round in this case. If your class size was 18, then yes, you would have to do some rounding. Okay, so there's how you do percentages. Number 5, do the numbers in the table in exercise 1. Summarize data on a categorical variable or a numerical variable. Well, what was the answers? Were they categories or were they numbers? So obviously chocolate, vanilla, and strawberry are categorical variables. Actually, let's say not said because chocolate, because flavors are categorical. Okay. Number 6. Do the students in your class represent a random sample of all the students in your school? Okay, and the answer to that is no. Okay. The reason is if you have a class, it's already a preset number of people that you're asking. So if we actually sat down and asked 20 students in a class, that is not a random sample. It is a predetermined set of people, if that makes sense. If I wanted to do random, I'd have the entire class of 8th graders, for instance, in the auditorium or cafeteria or somewhere, and I would walk around and I'd randomly choose certain students, maybe the third person at each table or something like that. So no, this is not random because the students, my pen is malfunctioning here. Okay, so the answer is no, because the students were not randomly chosen. Number 7, is your class representative of all the other classes in your school? Why or why not? So do you think the outcome would be the same? And in this case, you might say, maybe, maybe not, and give an example. So if we say yes, you might say, because I think the 8th grade class has the same tastes as our class. Or you might say no, because you think that our class, for some reason, you would think chocolate would be the most common, where vanilla was actually in our class. So number 8, do you think the principal will get an accurate estimate of the proportion of students who prefer each ice cream flavor for the whole school using only your class? Okay, and I would say that would be not Not likely. Okay, there are other reasons that we won't get to in this course, but our sample size is too small. I'll just say that. I would want to ask more students than 20 to represent an entire class. Okay, example 1. Students in a different class were asked the same question about their favorite ice cream flavors. The table below shows the ice cream flavors and the number of students who chose each flavor for that particular class. The table is called a one-way frequency table because it shows the counts of an univariate categorical variable. Okay, it shows counts of a univariate categorical variable. One thing is changing, the flavors. So the univariate categorical variable is the ice cream flavors, and the counts is the number of students. We compute relative frequency for each ice cream flavor by dividing the count by the total number of observations. Relative frequency is count of a category over the total number of observations. Since 11 out of 25 students answered chocolate, the relative frequency would be 11 out of 25, which is approximately 44%. This relative frequency shows that 44% of the class prefers chocolate ice cream. In other words, the relative frequency is the proportional value. Proportion being this here. We call it a ratio in math, but in statistics, that is a proportion. Proportional value that each category is of the whole amount. Exercise 9 and 10. Use the table for the preferred ice cream flavors from the class in example 1 to answer the following questions. What is the relative frequency for the category strawberries? So if I go back to my table that we filled out in this video, strawberry was 6 out of 20. Okay. So the relative frequency equals the count of the category, 11, divided by the total number observed. Well, there were 20 in the class that we asked. So 11 out of 20, so it's this here. And we already confirmed that this was, to make that a 100, you multiply by 5. So this is 55, or 0.55, or 55%. What is the relative frequency for the category? 0.55, or 55%. Okay, the relative frequency would be this right here. Number 10, write a sentence interpreting the relative frequency value in the context of the strawberry ice cream preference. Okay, so this is where the percent comes in. So I'd say 55% of the class prefers strawberry ice cream. Okay, example 2. The principal also wondered if boys and girls have different favorite ice cream flavors. She decided to redo the survey by taking a random sample of students from the school and recording both their favorite ice cream flavor and their genders. She asked the following 2 questions. Which of the following ice cream flavors is your favorite, chocolate, strawberry, or vanilla? What is your gender, male or female? The result of the surveys are as follows. Of the 30 students who preferred chocolate ice cream, 22 are male. Of the 25 students who preferred strawberry, 15 were female. And of the 27 students who preferred vanilla ice cream, 13 were male. The values of 2 variables, which were ice cream flavor and gender, were recorded in this survey. Since both the variables are categorical, the data is a bivariate categorical data. Can we display these data in one-way frequency table? Why or why not? And the answer is no, because we need 2 rows, not 1. And instead of just saying 1, I should say not a one-way table. We need a 2-way table. Okay. We're going to use a two-way table. So summarize the result of the second survey of favorite ice cream flavors in the following table. So now I have this table and I have to use the data that is on the previous page, unfortunately, but I can fix that. Okay, so I brought the data over to this page, so I don't have to keep going back and forth. And it says to summarize the results of the second survey of favorite ice cream flavors to the following table. 1 of 30 students who prefer chocolate ice cream. Of the 30 students who prefer chocolate. So that's the total. So here's chocolate. So we now know that there is a total of 30 students. Of the 30 students who prefer chocolate, 30 students prefer chocolate, 22 are male. I'm just going to enter the given information first. So there's that. And now it says of 25 students who prefer strawberry, here's strawberry, that's a total of 25 preferred strawberry, that's our total. And then it says 15 of them are female, so I'm going to put a 15 here. And then the next one says of 27 students who prefer vanilla, vanilla total is 27. Of those 27, 13 are male. So now we have to summarize this table. So here's the table, and we just need to finish filling it in. Well, if there were 22 males, we know how many females there were if we know the total's 30. It's just the total minus males, so the females is 8. Let me do that in a different color so you know what we calculated. So that is 8, because 22 plus 8 is 30. So we do the same here. To find males, we subtract females from the total. So 25 minus 15 is 10. And then the total was 27, subtract 13 males, and we get 14 females. So it's just addition. We need these columns to add up. Male plus female equals total. Male plus female equals total. Okay? And now that we've done that, now we can say chocolate plus strawberry plus vanilla equals the total males who like, or if we can find how many total males there are. So 22 plus 10 is 32, plus 13 is 45. So there are 45 males in this group. Females, there's 8 times 15, which is 23. And 23 plus 14 is 37 females in this group. 7 plus 5 is 12, carry the 1. 4 plus 3 is 7, plus 1 is 8. So then I should check going across here. 5 plus 2 is 12, carry the 1. 2, 4, 5, 6, 7, plus that carried 1 is 8. So what I'm saying is this plus this equals that, and this plus this equals that as well. So when you add, the rows have to add up, and the columns need to add up. So we just answered a whole bunch of questions here. We now know how many males and females and total, like chocolate, strawberry, vanilla, and we know how many total males there were, how many total females, and how many total males and females in this survey. So now it says to calculate the relative frequencies of the data in the table in exercise 12. So what we're going to do here is just simply take and fill this in with the data given. Okay, so what we're going to do is we are going to take each value and make that the numerator. So I'm going to have a fraction in each of these. So let's just start off by putting a fraction bar in. And we're going to do that for every single one. Okay, these are not minus signs. These are my division bars. And I'm just setting that up. We're going to do a ratio, or in this case, a proportion, because it's statistics. And I'm going to put the number that's in each of these squares in the numerator. So there were 22 who liked chocolate, and 8, and that totaled 30. And 10, and 15, and 25. I'm just putting my numbers in the numerators over here. 13, 14, 27, 45, 37, and 82. Okay, so we always want to take the frequency and divide it by the total. So let's go back and look at that formula again. Relative frequency is count for the category over the total number of observations. Well, our total number of observations in this situation were the 82. So the count is how many males like chocolate? 22 out of the 82. So 82 is going to be my denominator in this entire table. Just going to repeat 82 over and over and over. So it's 8 out of 82, 15 out of 82, 14 out of 82, 37 out of 82, 30 out of 82, and you get the idea. Okay, this one's easy. 82 out of 82 equals 1. So 1.0 is my 100% of the group is the 82, or 100%. Okay, so we're going to do approximations here. So this is approximate. We're going to do an approximation. So I'm going to do the squiggly equal sign, if you will, and that's our approximation symbol in math. Because we're going to round, and when you round, that's an approximation. Okay, so I just like to do it this way, and in this case it's equal. It doesn't have to be approximately, it is. All right, so I want to do 22 divided by 82. So the easiest way to do this is to take a calculator and just simply go 22 divided by 82 and hit enter. And it's 0.268, so let's round to 2 decimal places. So that's approximately 0.27. Okay, I'm not going to take the time to punch this all in. I'm just going to calculate it and off screen and write down what comes out. So 8 over 82 is approximately 0.10. 30 out of 82 is approximately 0.37. 10 out of 82 is approximately 0.12. And 15 out of 82 is approximately 0.18. 25 out of 82 is approximately 0.30. 13 out of 82 is approximately 0.16, and this one's approximately 0.17, and approximately 0.33, and this one is approximately 0.55, and this one's approximately 0.45. So we could be off by a tenth here because we've done some rounding, but 55 plus 45 equals 100, or 0.1, or 1.0. 0.37 plus 0.3 is 0.67, plus 0.33 is 1. Okay, so those all check out. 12 plus 18 is 30, 27 plus 10, 37, 16 plus 17, 33. Everything adds up nicely, and there is our relative frequency bivariate data table. Okay. Use the relative frequency value in the table to answer the following questions now. What is the proportion of students who prefer chocolate ice cream? So the total who prefer chocolate is over here. I'm sorry, down here. Chocolate, the total is down here. Chocolate total right here. And it was 30.37 or 37%. What is the proportion of students who are female and prefer vanilla ice cream? So now we're doing an and thing. So we want female that prefer vanilla. Well, that's right here. Female, vanilla. Where do they intersect? At the 17. So that is 0.17. Okay, number 15 says, what is the proportion of students who are female? Oh, I'm sorry, 16. Write a sentence explaining the meaning of the approximate relative frequency of 0.55. So I look up here and I'm looking for 0.55 and it's right here. Well, that's the total males in the survey. So you would say approximately, is not exact, 55% of students responding to survey are male. Number 17 says, write a sentence explaining the meaning of the approximate relative frequency 0.10. Okay, so now I want to go back and look at my table and find 0.10. And that is right here. Okay, we'll use a different color. Let's go to red. It is this one here, and that is females who like chocolate. So I would say approximately 10% of the students responding to the survey are female and prefer chocolate. Okay, approximately 10% of the students responding to the survey are female and prefer chocolate. Okay, moving along. Example 3. In the previous exercises, you used the total number of students to calculate relative frequencies. These relative frequencies were the proportion of the whole group who answered the survey a certain way. Sometimes we use row or column totals to calculate relative frequencies. We call these row relative frequencies or column relative frequencies. Below is the two-way frequency table for your reference. To calculate the proportion of male students who prefer chocolate ice cream, divide the 22 males, which is here, males who preferred chocolate, okay, intersect right here. Divide the 22 male students who prefer the chocolate ice cream by the total 45 males, not the total students. Okay, we're looking for the proportion of male students who preferred chocolate, not the total students. So you need to be careful with that. Note that you use the row total to make this calculation. This is a row relative frequency, okay, because we use this row for our information. 22 like chocolate out of the total of the males. That is a row frequency. Okay, in exercise 13, now let me erase all that. In exercise 13, you used the total number of students to calculate relative frequencies. These relative frequencies were the proportion of the whole group who answered the survey a certain way. 18 says to suppose that you are interested in the proportion of male students who prefer chocolate. So you want to look at just male students. Okay? How is this value different from the proportion of students who are male and prefer chocolate ice cream? Discuss with your neighbor. So now they're saying, suppose you're interested in the proportion of male students who prefer chocolate ice cream. Now we're talking about who prefer chocolate. That's our total now. So that would be here. How many males prefer chocolate? So the total chocolate is 30. Okay? Before we were saying, of the total males, how many preferred chocolate? Now we're saying, of the males who preferred chocolate. There's the difference. The proportion of male students who prefer chocolate. What proportion of males preferred chocolate instead of what proportion of the males preferred chocolate? See the difference? Okay, so it can get a little tricky here. Male students who prefer chocolate ice cream. So the preference is the column. All right. Okay, so now let's put this to bed here. Suppose you are interested in the proportion of male students who preferred chocolate ice cream. How is this value different from the proportion of students who are male and prefer chocolate ice cream? Okay, so the proportion of students who are male and prefer chocolate ice cream is 22 out of 82. Students who are male and prefer chocolate. So you're saying male and chocolate out of the total. Okay, and then we continue with that and we say this proportion uses all 82 students. The proportion of male students who prefer chocolate ice cream is 22 out of 45. This proportion uses only 45 male students and its total. So if I use this green square, I could say of the total students who preferred chocolate, how many were male? So the first thing that you read is what tells you the total. So I'm going to delete that green square here. Okay, so this says, suppose you're interested in the proportion of male students who prefer chocolate. Male students who prefer chocolate. Right there. And that's what this is here. 22 out of the total. But then if we say the proportion of male students who prefer chocolate ice cream, the proportion of male, so we're saying the proportion of male students who prefer chocolate ice cream. We're just talking about the male students. This says proportion of students. That is the difference. The proportion of students, that's all. The proportion of male students is all the males. That is the difference. Okay. 19. Use the table provided in example 3 to calculate the following relative frequency. What proportion of students who prefer vanilla ice cream? So the proportion of students who prefer vanilla ice cream. So vanilla is total vanilla. So we're talking about students. Let me erase all this stuff here. Hang on. Let's make this table's getting a little messy. So, proportion of students who prefer vanilla ice cream. So we're just focusing on the vanilla. That's right here. Of those, how many are female? So the proportion would be 14 out of 27, which is approximately 0.52 or 52% of the population. Okay, number 20. What is the proportion of male students prefer what proportion of male students? Okay, proportion of male students prefer strawberry. So the proportion of male is my denominator, and those that prefer strawberry is my numerator. Okay, so I need to go back and see how many male students there are. And let's erase this. Okay, so now we're talking about just the male students. So that's this row. So this is a row relative frequency. Okay, so of the males, what proportion of male students, that's the total, and that is 45. Sorry about going back and forth here, but that is 45. That's our total. Of those 45, how many of those guys prefer vanilla ice cream? And the answer is 13. Or was it strawberry? It was strawberry, now that I think about it. So it was that one. Let's make sure. Strawberry? Yes, strawberry. So that is 10. So it's 10 out of 45, which is approximately 22%. C says, what proportion of female students? Okay, that first piece there tells you your denominator. I'm going to draw a line here. Proportion of female students. So when I go over, I'm just talking about the female students now. So that is going to be this row, just talking about the females. And we want to know what proportion of them prefer strawberry ice cream. So I want to move this strawberry down to here. So the total's 37. The ones who prefer strawberry was 15. So my proportion is 15 out of 37. And that is approximately 41%. What proportion of students who prefer strawberry ice cream? That is my denominator. Proportion of students who prefer strawberry. So I go back and I look for the strawberry total. Now it is a column relative frequency, not a row relative frequency. So now we're talking about the strawberry column, and the total's 25. So I come back over and I put 25 in my denominator, and my numerator is the R statement. Of that total, how many are female? So I go back and I look, and the female is 15 out of 25. Okay, and I see that this is 25, and that'll go into 100, so I'm going to multiply by 4 over 4, and that will give me 60 out of 100, which equals 0.60. Okay, and let's still use an approximation here, even though it is equal this time, but let's keep it as approximately 60%, because remember, this is just a frequency table, and it's an approximation. Okay, so I made it a little bit easier here so we don't have to go back and forth. So here is number 20. A student is selected at random from the school. What would you predict the student's favorite ice cream to be? And explain why you chose that flavor. So I would say I predict that the student's favorite flavor is Okay. I look up here, and these are the three flavors. 27, 25, and 30 out of 82. This is my total, and 30 is more than 25 and 27. So I would predict that students' favorite flavor would be chocolate. Because more students in the survey chose chocolate. Okay. Now let's erase that and answer the next question. Now it says, suppose that the randomly selected student is male. What would you predict his favorite flavor of ice cream to be? So what they're saying is, now that we know that we chose a male, and we want to predict their favorite flavor of males, then you would then answer the question by saying what? And I said I would predict his favorite flavor is, and if you look at just the males, the total's 45, 13 liked vanilla, 10 liked strawberry, but 22 like chocolate, and that's higher than these two. So it'd still be chocolate. And I'd say because more male students in the survey chose chocolate, and I'm not going to write that. Number 22, suppose the randomly selected student is female. Okay, I'm going to stop right there. I'm going to move this down to female. Suppose the randomly selected student is female. What would you predict her favorite flavor ice cream to be? So I would move this circle. 8 is the least, 15 is the most. It's more than 14 and 8. So therefore, I would predict her favorite flavor to be... Ooh. I would predict her favorite flavor to be strawberry. Because more girls chose strawberry over the other two. And I'm not going to write that. Okay. So that is the end of lesson 13. Review the lesson summary and go do your problem set.